All right. So here we are. Pretty much every question in this, you're going to be doing something yourself as well as writing stuff down. So let us begin with this. First of all, does this graph have everything a graph needs? It's got a title. It's got a scale. It's got a scale on both axes. Both axes are labeled. Yes? All right. Now listen to me. Do not automatically assume that the independent variable is on the x-axis, because it is not always on the x-axis. You must understand what the independent variable is. So everybody, have a look at these. I'm asking you for the IV, and I'm asking you for the DV. You can talk to your neighbor and find out which is which, but remember, I want you to be able to explain why. And the answer cannot be because one's on the x-axis and one's on the y-axis. Okay? Everybody understand? So go ahead and tell me which is which. Write it down and think of your reason. But do not have that reason have anything to do with axes. Go. All right. Who would like to tell me what they think the independent variable is? The time. Why do you think that? You're on the right track. I like your reasoning. I would give you some marks. Anybody got another reason?
For what?
First of all, Amrit is right. Independent variable is time. So if you didn't have that, or you wrote that because time is on the x-axis, you need to pay very close attention to the reason. Amrit's reason was almost right. Akash. There you go. Time is passing either way. You guys are all on the boat. I'm diving. Is time still passing? Yes. Your depth isn't changing. You're on the boat. But my depth is. The longer I'm under, every time, as long as I'm underwater, I have a depth. Understand? So my input is time. Time is passing regardless. Everybody good? Which automatically makes the dv the depth. Now, let's make sure we can actually read that bad boy. How long did the dive last? 30 minutes. How do you know that, Brooklyn? Because the graph, you were back at a zero depth out here at 30 minutes. And you can quite plainly see every square is 2 minutes. Yes? All right. At what times did the diver stop her descent? When did she float? From at what times? 4 to 8 minutes. And 10 to 14 minutes. How did you know? Flat line. So depth was not changing. Now you guys are smart kids. Can time ever stop? No. Can time ever go backwards? No. Can time ever be negative? What do you mean? What does that mean, Yash? Can you go back in time? So can the line for time on a graph ever go backwards? No, because time can't go backwards unless you have a 1985 DeLorean powered by plutonium and a flux capacitor. There you go. Did you actually watch the movie?
I have. I did. Kid went there on his bike.
Yeah.
Which movie is that?
Back to the Future.
And then he gets stuck there because the thing breaks.
Yes. Spoiler alert. You're silly. It's a great movie. All right. So guys, that should tell you something. On a graph, if you have a flat line, what does that mean?
Same depth.
No, on this graph it means same depth. What does it mean on every graph? It means the dependent variable isn't changing. Is everybody with me on that? Whatever you are measuring, if the line is flat, the dependent variable isn't changing. Next question. Can you ever have a vertical line on a graph that has time? Why? Because time is always moving, right? So if a flat line means there's no change, and a vertical line is impossible, then what does this steepness of the line represent? If this is not moving, and this is so fast it's impossible because time has to keep moving, what does this range mean? What's decreasing or increasing? On this graph, it's depth. What is it on every graph? The dependent variable. If it's really steep, how fast is it changing? Really fast. Because there's a big change vertical in a little change horizontal. What if it's really flat? Not quite flat. Moving very little as time goes on. A lot of time passing, very little change. Everybody with me? The spread from there to there is what we call the rate of change. The closer you are to vertical, the faster the thing is moving. In most graphs. Okay? What it's really telling you is how much dV change in the same amount of IV change. So on this graph, we're measuring meters and minutes. So the rate of change is how many meters happen in how many minutes. Everybody good? All right. So, what was her greatest depth? 20 meters. Now, this causes trouble for kids because she has gotten to a depth of 20, yes? But isn't 20 below the surface? So, shouldn't it be negative 20? It's actually, no, David, because we are measuring the depth that she has achieved. We are measuring a magnitude, not a direction. We're going to talk about that in a minute. Everybody cool? So even though she has dove under the water, the graph has to go up. That's a big mistake kids make. They think this graph is not a representation of data. They think this graph is a representation of what is happening. Do you understand the difference? A graph represents data. It does not draw a picture of what is happening. And finally, how long did she spend at that depth? 4 minutes. And now state the domain and range. What is the domain? 0 to what? How is what 4 minutes? She was at 20 meters for 4 minutes. 2, 4. So now, Simran, the domain starts at 0. It's 0 included. Yes? And what goes here? Do I put an X here? No. No. Time. Because I don't just have X and Y here. I have a domain. And what does it go up to? 30. Because the dive ends at 30. And I can also write it as 0, 30. What's the range? Zero. What goes here? Depth. Excellent. And I can write it as 0, 20. It's coming. What? Yep. You know, I'm going to give everyone fair warning. Don't bother asking me to leave the room within a half an hour of any breaks. Okay? Everybody cool? All right, let's look at the next one. This next question is asking you, there's all the information. I want you to tell me what is happening. Now listen to me. This is not English class. I'm not going to give you bonus points if your story is good and interesting and has a beginning, a middle, and an end, and there is rising action and a climax, and there is denouement, and there is conflict of man versus man, and man versus himself, or man versus his environment, or, of course, person versus all those things. None of that matters. Just tell me what's happening. Go. You can talk to your neighbor. Just tell me something that could be happening in real life to explain this data.
What is the volume of water? That's something like that, right?
What do you mean?
Like it says the volume of water in a watering. Oh, what's the watering? Oh, yeah, like the garden thing, right? Okay, I get it.
Okay. How many things happen in this graph?
Added water. Tested for things.
3 things happen, yes?
Yeah.
Something happens from A to B. What happens?
Added volume getting increased.
So that's what the graph is telling me. What's happening in real life?
You're filling up the water.
She's filling up the watering can. Was the watering can empty?
Yes.
No. It had 1 liter in it. So she fills the half full can. What happens from B to C? She does, nothing happens to the volume, but what's happening in real life, Brooklyn? Or what could be happening? She walks to the flowers because the water level isn't changing. What happens from C to D? Pours out the water. How fast?
180, 90.
1.75 liters in how many seconds? No.
20 seconds.
In 10
Oh,
seconds. Because she was up here at 2, or at 1.75. She poured out 1.75 liters in 10. Sorry, it's 20. 10, 20 seconds. Sorry. In 20 seconds. Now, I thought you were a math student. Now, would we ever measure a rate of change in a period of time like 20 seconds? No. What do we measure our rates of change in? How many units? 1 unit, right? You don't say I'm driving down the freeway at 120 kilometers per 2 hours, do you? No. You would never say I sleep 16 hours per 2 days, would you? We always do it in 1, yes? So I don't want 20 seconds. What do I want? 1. So I have this fraction, 1.75 liters in 20 seconds. What do I really want? In 1 second. So what do I have to do? Divide. And what's the answer? 0.0875 liters per second. Everybody good? Okay. Now, please notice there was nothing complicated here. When I give questions like this on a test, I watch kids stressing and they write a half-page story. They literally write a story, Amrit. Like, she woke up and it was a sunny day, so she wanted to make sure her garden was watered before it got too hot and the water evaporated. So she went outside in her Crocs and gardening outfit, and I read it. And I'm like, yeah, that's awesome. It's out of 3 marks. You get 3 marks. Kid beside her writes this. Fills the can, walks the flower, dumps it out. Gets 3 marks. Okay? This isn't English class. Exactly. Right? I have kids that stress about stuff like that. I had another kid once. He had to sketch a graph. The kid drew graph paper. He got out his ruler and he went, and he drew this line, he went, then he got out his ruler and he made graph paper. Okay. All right, now let's see if you guys can really do this. Here's a graph. Why does this graph not have any negatives? Because you can't have negative time and you can't have negative distance. No. We'll talk about that in a minute. All right? Listen to me. Those of you that cannot do anything in pencil, no names mentioned, should really do this graph in pencil because you're gonna do it wrong. Go. Try to draw this graph in pencil. And it needn't be perfect. You do not need to get out a ruler. Just sketch. This scenario, these 4 things that happen on a graph. And remember, graphs need 4 things. I'm going to have a sip of coffee while I wait for you guys to try and do this right. Yes, of course you can, because you didn't just have a 15-minute break where you could have gone to the vending machine. Of course you can, because you didn't have a 15-minute break when you could have gone to the vending machine. You know what? I like my sarcasm too, but it doesn't seem to help. See, here's the thing, Ekdeep. I used to just say no.
Yeah.
And kids would be, you're so mean, you're such a dick. Okay, fine. So then I moved to this.
Yeah.
But now, people still leaving.
Good now.
I have a right to teach math without having my class interrupted. These 25 people have a right to math being taught to them without one of you every 2 seconds. Can I go bathroom? Can I go bathroom? Can I go bathroom? I gotta go bathroom. I'm hungry. Can I go vending machine? Can I go vending machine? Can I go bathroom? You might notice that I too have a body that works. You might notice how rarely I leave, even though my plumbing is over double as old as yours. No, it means I can hold it like a real man. No, I am saying that you people are not used to ever being uncomfortable for a millisecond. Awesome. Just finished messaging with the people in Toronto to send me my hot sauce. I have to get my hot sauce from Toronto. We had this long discussion. You were busy.
Yeah, he was sarcastic.
No, that isn't at all what I said. Fortunately, I have it all on video, so. Alright. Oh, okay, David, we'll wait for you. I got nothing but time. However, time is not going backwards. Time is not money, except in that awesome Justin Timberlake movie.
Yeah, time is money.
What was it called? Time's Up? When they had the time tattooed on their arm.
That's such a good movie.
Yeah, it was a great movie. Was it Justin Timberlake? Guy, he's such a good actor and so good looking. And so talented.
Oh, the.
I can't remember who the girl in it was.
Amanda.
I don't remember.
There's a chick from Mamma Mia.
From which?
From Mamma Mia.
Oh. I was watching School of Rock yesterday, not the Netflix TV show, the actual movie, and iCarly was in it.
iCarly or Carly?
iCarly, Miranda Cosgrove was in School of Rock. I didn't know that the first time I saw it because I wasn't an iCarly fan. Now I'm a huge fan of iCarly. iCarly is brilliant comedy.
She's in Despicable Me too.
iCarly is so what?
Jake and Josh.
What was that, Alex?
She's in Despicable Me too.
Who
Is she? Oh yeah, she's one of the voices. Yeah, she's the daughter, right? Yeah, the eldest one. Yeah.
You want Jake and Josh?
I love, and what is funny about iCarly is I used to make fun of it before my kids started watching, and I started watching it and realized how funny it was.
I don't remember.
And now what I think is even funnier is when you watch grown-up TV shows that win like awards and stuff, they do some of the same gags that were on iCarly, and then when you look at who the writers are, it's the same dudes. But on iCarly, oh my God, it's such a stupid kids show. Put it on a show like Modern Family. Oh, it's brilliant. It deserves an Emmy.
That is a good show.
Modern Family is a good show.
How about your mother?
Yeah, it's a great show.
That's all.
It's no Brooklyn Nine-Nine, but it's a good show. Brooklyn Nine-Nine is the best show on
What is it
television.
about?
How I Met Your Mother is the
How I Met Your Mother is not on television anymore,
I have
on
no
Netflix.
but it was awesome.
90210 is a really good show.
Oh my
I love that
God.
show.
You're so, oh my God. Old 90210 was awesome. New 90210 is lame.
Oh,
The old one from the 80s.
no, the
I know you mean the new one. Just like you also think Riverdale was good too. Even though it wasn't. Archie is not a murderer. There was no murders in Riverdale. They had fun. They ate hot dogs at the chocolate shop. There were no murders.
It's based off of it, though.
It's based off of it, meaning the characters have the same name.
School and the name, like the city and like.
Yes, well, the city is Mission, so.
And all the Grove and Vancouver.
Yeah. All right, here we go. I believe that everybody will have done A right. What is down here? Time or distance? Time. Excellent. And what is that time measured in?
Hours.
Excellent. Good. 1, 2, 3, and so on. What is on this side? Distance. And it is measured in kilometers. Excellent. The first 2 hours of his trip, Jack leaves home and travels 140 kilometers at a constant speed. So I'm going to go up by 20s. 40, 60, 80, 100, 120, 140. Everyone agree? So from 0 to 2 up to 140, what kind of line must I connect there? Straight. Why?
Consistent.
Because it was a constant speed. Now, is that actually possible?
Yes.
Constant. Is that actually possible? No, of course not. Because when you get in your car, you are not driving 70 kilometers an hour. You have to get up to that speed, right? And while you were in that car, you were probably going to have stoplights and left turns and things like that.
Unless you're on the highway.
Traffic.
But even on the highway, you have to get to the highway. Unless you live on that strip of land between the two parts
Avril lives there.
in a tent down by the river. Okay, so it's not really possible, but did everybody draw that appropriately?
Yeah.
0 to 140, 0 to 2, straight line, yeah? All right, everybody did section A right. Visits grandma for 1 hour. What kind of line?
Straight.
Well, they're all straight. Flat. Why?
Flat.
Because he's not moving, but time is going on for 1 hour. So there's A, there's B. 2 to 3, that's 1 hour.
Oh, my bad. I have a quick
What?
question.
Yes, David.
If it's 140 kilometers and we stay at the top going flat, wouldn't that mean we're going at 140?
No, David, because this is measuring distance.
Oh.
Am I moving right now?
Never mind, I thought this was yes.
The planet is moving, yes. All right, everybody good to there? All right, now, right here is where most of you are going to go wrong. What is the next part of the line? Where do I go from here? I need to go 50 kilometers back towards home and then stop for supper. There's a couple of things wrong with this. One, I do not say how long it takes to drive that 50 kilometers, do I? Okay, so that's one problem. So you got to guess that. But 50 kilometers, I got to go back down to 90, yeah? So 20, 40, I got to come back down somewhere to around 90 here, yeah? Everybody agree?
Yeah.
How many people drew this line? Put your hand up. If you bothered to draw it, how many people drew that line? The line I just drew. You're all wrong. Why are you wrong?
It doesn't take that long.
Nope.
This is the distance.
Because it's the distance you travel. So where does that line have to go? Up, because my distance is continuing onwards. Like when you drive your car, the odometer goes up, even when you drive in reverse. When I drive to Vancouver, I add 200 kilometers. When I drive home, does 200 kilometers come off my odometer? No. So, this has to go up for 50 more kilometers to 190. Now, please stop. If you drew this line, which I'm going to draw in red, it has value, and I'm going to talk about it in a minute. But if you drew this line wrong, Fix it now. What then happened for 30 minutes after I drove? I ate some supper for 30 minutes. So half an hour, I got a flat line. So here I am at, say, 4.5. Now I drive home for 2 more hours. So where does the line go from there? Up. And I go 2 hours. How far does this have to go up? Well, I drove 140. I drove home 50. So this has to go up how far? No. I've already driven home 50. So
90.
this has got to go up 90, and this has to be 2 hours. Is everybody good? Okay. Yes, Amber. I have to go bathroom. Okay. What? Okay. What? Dinner. It's just another word for dinner. Your evening meal. Okay. Now, guys, remember I said this red line down here has value, right? Because this is what most of you drew, correct? This is the distance line, because distance is what we call a magnitude. It simply has a value, okay? This is what we call displacement, which is a vector. And a vector has a value and a direction. And here is what I mean by that. This really needs to be visual. I am standing still. This is my starting position. What number would you assign to this position? 0. 0. So we start counting from 0, yes? Okay. From your people's perspective, so ignore my left and right hand. From your people's perspective, tell me the direction. No. Tell me the distance I move. Everybody ready? What was my distance?
2 steps.
2 steps. Now I'm going to return.
4.
How many steps did my body pass through? 4. That is a distance. That is a magnitude. Is everybody cool?
Yes.
Now, give it a direction.
2 steps left.
2 steps left. Now, for you guys, as math and science people, we designate left as negative. So I have taken negative 2 steps in displacement. Do you all understand?
Yes.
We also designate east as negative. We designate backwards as negative. We designate down as negative. We designate south as negative. Is everybody cool?
Yeah.
All of those are designated as negative. Now, what did I just do there? 2 steps right, which must be positive. So my distance was 4. What's my displacement? 0. Because I did negative 2, then positive 2. Does everybody understand?
Yeah.
So this red line is the same information, but it's graphed as displacement because I return to my home, to the origin. Everybody with me?
Yeah.
That graph we had of the diver, was that displacement or distance? Displacement, because she returned to the surface. Got it?
Yeah.
If I only asked you how far she traveled, it would have been zip, 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 up to the flat point, and then it would have carried on going up because she passed through that same 20 meters. Does everybody have it? Okay. If you've done Science 10, you did a lot of that in Science 10 as well. all the drawings of the kids on the skateboards.
Physics.
Yeah. That's okay, Amaranth. Okay, so everybody is good with vectors and magnitudes?
Yes.
That's what this big space in the middle is. If you need to write it down, you may want to. Positive vectors are right, up, north, west, forward is another one. And then negative vectors are all the opposites. Left, down, south, east. Oh, I lied. Those are backwards. I'm sorry, guys. I'm such a moron. East, west. What the Vietnamese soup? Backward. Yeah, the smoke's starting to get down here. You can't even see Mount Cheam and Chilliwack. Yeah.
Forest fires. Did you watch the news? I don't see any smoke.
Wait, can you go back up, please?
Go back up, please. I can see
It was lagging.
Yeah. East is positive. I don't know.
They're painting the school.
All right. So now you guys look at this graph. Look very carefully at the scales and tell me what is happening.
Wait, it looks like a drag race. Drag race.
Okay.
Because it accelerates the speed and
Absolutely correct. Nice job. From 0 to 2 seconds, what's happening? She accelerates. Because her speed started at 0, because this is graphing speed, and went in 2 seconds from 0 up to a speed of 8 meters per second. Okay? That is 28 kilometers an hour. It is if she's running on foot. Doesn't say it's a car. All right. What happens from 2 to 14 seconds? She maintains constant speed. Now, I'm glad nobody said she stops. If this was a distance time graph, has she stopped moving? Yes, but it's not. It's speed and time. So her speed stayed at 8 meters per second. What happened at 14 seconds? Why? Well, she crossed the finish line. Maybe she won. She crosses line. And what happens?
she wins.
Maybe.
She wins.
She stops. Okay, if she stops, that must mean her speed is from... Right. So why isn't it a straight up and down line?
because it takes time.
Because it takes time to stop, unless she runs into a wall. Then it's an up and down line. Everybody good? Yeah? All right. Turn the page over. 1, 2, 3. You do not have to do graph 8. 4. I want you to do 5, 6, and 7. Go. They can just be sketched. They don't need to be perfect. You don't need titles and everything. You just need to label your axes. Go. And you're not going to do number 8. You don't have to do number 8. I'm going to do number 8. You're going to take them as notes. And as of here, you're going to have a quiz tomorrow.
On what?
I'm about to tell you.
We're having a test tomorrow.
I know you are, but every day is a week. So tomorrow's day is actually covering 5 classes worth. It's not odd to have a test and a quiz over the course of 5 classes.
Do you have a quiz tomorrow on this?
Yes, on domain and range and on graphing. So I'm going to let you guys finish these off for a couple of moments, then we're going to draw the last one together. Sketch and label a graph. Don't use the whole space in case you're completely wrong and need to redraw it over here.
You don't need.
Time is up. That was the text tone for my Chinese exchange student. It was a gong. I'm about to get a Mexican exchange student, so I'm going to make it La Cucaracha when he calls me. Da, 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 da. Or it might be, ole, 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 ole. I can't decide. Maybe one will be his ringtone and one will be his text tone.
Do you still have the Chinese?
No, he got sent home because he got drunk.
Really?
Yeah. He went out Friday night with one of his buddies who's 19, and they got all liquored up at a Chinese restaurant.
How
And then
old
my kid was smart enough. He was like, oh, and he came right home. But the other two stayed out partying, and one of them got so drunk he passed out, and they had to call an ambulance and stuff. And then the one who was 19 was like, I don't know where he is.
How old is
He was 17. All four of them got sent home.
Wait, your son was.
Well, not my son, my Chinese exchange student.
Why are you texting me?
Who?
Why do you?
No, when he was texting me. I just used that sound to end your time.
Oh, why is he
Oh, I thought
texting
you
me?
No.
texted you.
No.
Why do you?
I thought you said what's up.
What's that?
You talking
No.
still?
No,
Why not?
because he's in Toronto.
Oh, I thought
It's not like we were friends.
Then how did he exchange student?
Why does he have your number? I don't know. Why do you have his number?
I don't anymore. This is my buddy who's a farmer. This is my brother
Why is that?
because his name is Michael Myers, and that's the theme song from Halloween. The killer is named Michael Myers. And because when my brother phones me, it's horrifying for me. What else do I have?
Did you pay for all these ringtones?
Hello, nurse.
No, they're on an app. My buddy who's on my hockey team.
You bought
Yeah.
all of these?
That's my buddy who's crazy because he's Looney Tunes. This is my text tone for people who I don't know who you are. If you don't deserve your own ringtone, you get that. I wonder what this is.
Spit nipply out.
Oh.
Tiny nippy out.
It's from Christmas Vacation. Love that movie. All right, so what goes where on your graph? First of all, do I need negatives? No, why? Time can't go into negative and height can't go under the ground when you're on a swing. If your swing went under the ground, that would be pretty painful. Whee! Thud! Oh! So, what's down here? Time. What's here? Height. Where does your graph start? At 0? No. Because your swing is not sitting on the ground or it wouldn't swing very well.
When you sit on it, it's still. It's not moving.
Yeah, but it's not.
It's not on the ground. So you have to start up here a little bit, yes? Now, as I swing, how do I start swinging?
Higher, higher, and higher.
I gotta jump either forward or backward, yes? So what happens to my height? It goes up a little bit. And then what?
Then you go faster and it goes
Then it goes down back to where?
where you started.
To 0. And then if I can swing properly, what happens next? It goes a little bit higher and a little bit faster. And then it goes back down to 0. And then a little bit higher and a little bit faster. And a little bit higher and a little bit faster. It does not do this. Hey, you have any idea how many tests I've marked where the kids have told me that's the graph of a kid on a swing? Because apparently that kid is swinging so fast he's in hyperspace and is going back in time. Because kids don't listen. Now, also, because that's all kids care about. Also, there's a maximum height, isn't there?
5 meters.
Whatever it is. You will not flip over. You cannot swing a swing around. Even though all of you say, I have a buddy that did it once. You can't.
I've seen a video on YouTube.
No, you can't. And I saw a video on YouTube, so it's real. I saw this video on YouTube where they faked the moon landing because nobody got to the moon. If it's on YouTube, it's real. It's got to be real. It's on YouTube. Everything on the internet's real. I saw it, so it's real. You cannot swing a swing all the way around. It is impossible unless you have extra propellants. And even then, they've got to be going so fast that you wouldn't make it anyway.
What if you weren't on it and just like...
At some point today, Yashvinder is going to say, Mr. Mars, I don't understand something. All right. Look at number 6. Distance time graph for a runner completing a 400-meter race. What's down here? Time. What's here? Distance. Where's the first dot go? On which scale? On both, because I'm at the starting line. I haven't traveled at all. What does it go up to? 400 is the maximum I can achieve. Yes. Now, how would it look? How do you start in a race?
You accelerate.
You accelerate, right?
Yeah.
So you're going to cover a lot of ground in a little time, or a little ground in a lot of time?
A lot of ground in a little time.
Lot of ground in a little bit of time. So the first little bit is going to be really steep, isn't it? And then what happens? You slow down, you settle down into a pace, right? So is distance still going up?
Yeah, because you're running.
Yeah, it is. I'm still moving. So distance is still going up, but it's going up less steep. What happens when I get close to the finish line?
You go faster.
You sprint to cover the last little bit of distance in as little time as possible. That's what your graph should look like.
This is 40 degrees.
I just did like a straight, completely diagonal line.
That would mean you ran the whole race at the same speed. David, is that a smart way to run a race?
I know, but
Slow and steady wins the race only in the tortoise and the hare, David. The rest of the time,
I would do
fast
that.
wins the race.
Because I would do that.
Well, because you're going to get a participation ribbon, so you might as well.
Exactly.
Run slow in the beginning.
Huh?
You win.
What?
It's a 400-meter race.
Yeah, if you go for like slow for the first 200 meters, you sprint the rest.
400 meters.
That's fine. The point I'm trying to make, Amrit, is you have to have more than one section if you were running a race. What is different about number 7? It's displacement on a track. So where will the graph end up? Back at 0. Will it end up back at 0 here or out here? Out there, because why?
Because you're not going
The time.
Time can't go backwards.
I wish it could though.
Now, it gets a little weird though, right? When I leave the starting line, I'm going away from it, yes? So is it positive or negative? Positive. So my distance, my displacement, which is over here now, it's not distance, has to go up, yeah?
Yes.
Everyone agree?
Yes.
So here's my track. There's the starting point, yeah? So as I go out here, I'm going further and further away. What happens as I turn this corner? Is my distance from start? We'll finish this up when you're back. All right. So, as I was saying, when I first leave on a track, my displacement goes up quite a bit, doesn't it? Right? Because I'm going further away. But as I start to curve, I'm still getting further and further away from where I started. But is it happening as fast? No. So what has to happen to the line? No. Not down, because I'm not coming back towards home. It keeps going up, but it can't go up as steeply, right? Because it's getting less and less and less, yeah? Now, when I get to this point right here, that is my maximum distance from start, isn't it? Right? So at that point right there, I hit my maximum displacement. Yes? So what starts happening here as I turn back around? I'm coming back to this point. Now, is this point the start? No, but the displacement is not very far, is it? So I got to start coming down a little, don't I? Everyone agree? Then I get to here, and then what happens to this displacement? It gets longer back up to the maximum, and then what happens once I hit this maximum? It's getting shorter again until when? Back to 0, because eventually I end up back here. Is everybody with me? Again, I am not marking you on your actual measurements. I am marking you on your ability to show me that you understand the difference between displacement and distance. Distance, it's got to keep going up. Displacement, it goes back to the beginning. That's it. Everybody cool? All right, now I said we were going to do 8 together. You guys aren't going to do it because if you guys all did it, there'd need to be 25 different graphs. So we'll do the one for me. All right? So position time graph. Distance or displacement? Displacement, right? Okay. So from me to school, I live in Chilliwack. So time, displacement. As I leave my house, what happens? Right. How fast? Do you think? I live in the middle of Chilliwack in a regular neighborhood. So not very fast, right? So as time moves on, we'll go in 15-minute increments. 15, 30, 45, 1. Actually, we'll do this differently. We'll go in 5s. 5, 10, 15, 20, 25, 30, 35. Okay. So for the first 5 minutes, how do you think it looks? Yeah. So it's going to be a steep or a shallow line? Right. I live exactly 8 kilometers from the highway. Okay? So let's go up by 5, 10, 15, 20, 25, 30, 35. All right. So I got to go 8 kilometers, and it takes me about 8 minutes. Right? So I'm going to go out to 8 minutes, up to 8 kilometers. Now, that's how far. Now, is it technically going to be a straight line? Do you think?
No,
Why?
because it's stopped.
Stop signs, stop lights, turns, all that stuff, right? So, for graphing purposes, though, we're going to say it's a nice straight line. Because you go about 60. Nobody goes 50, right? So it's about 1 kilometer a minute. Everybody cool? All right. What happens there? What do I hit? The highway, right? Which means I'm going to go 120 kilometers an hour, not 60. So if this steepness is this, what has to happen there? It's got to go up. How much? Significantly steeper, yes? Double. So if it took me 8 minutes to go 8K, I'm going to double that. So I would go 16K in 8 minutes, yes? Now I'll tell you, I go on the highway from exit 116 to exit 87. All right? That's 29 kilometers. If I'm going 120, let's call it 30 kilometers. So if I'm going 120, that's 2 kilometers a second, yeah? A minute, right? So it's going to take me how long to get from my house to the Clearbrook exit? 15 minutes, right? So here I am at 8 minutes. 15 minutes from there is 23 minutes, yes? So I'd be up at 23. Out here at 23. And what distance would I have traveled? 8 kilometers plus the 16 plus 13 is 29. So 8 kilometers and 29 is 37 kilometers, yes? So out here at 25, I got to be up here at 37K. I should have gone to 40. So up here at 37K at 23 minutes. Now, is that one in reality going to be a pretty straight line? I'm on the highway. Is it going to be pretty constant? Yeah, on the highway. Unless there's traffic, it's going to be pretty constant, right? Now, what happens when I get to that exit? I don't go down because I'm still covering distance. What happens to the steepness of the line? Goes way back down because I'm driving in the city now with stoplights. Everybody with me? Everybody good? I didn't draw it very well. I should have stretched the time out so the graph stretched onwards. But it would go down flatter. And then I arrive here at Mowat. Now, if it's displacement, what does this graph look like going home? Let's change it up a little. I start out this way, then I go flat, and then I go that way. What's it look like going home? If it's displacement.
Same thing.
Exact same thing, mirror image, yes? Assuming no traffic, assuming all the conditions are the same. Right? Big, steep, then like that. What if it's distance? This is displacement. If it's distance, this would keep going at that same level, then get super steep, and then go flat again as I get closer to home. Everybody got graphing? Okay, I'm going to shut up. You're going to do page 154. Until 12:30. Then I'm going to do one last little bit of notes. And I'm going to shut up then and let you prepare for your test and quiz tomorrow. You're doing page 154 right now till 12:25-ish. Or until I decide more people are not working than are. Because once I hear more people not working than are working, that means you all must be done, which means I can go on with my class. At which point I will do the notes on 156. And then I will shut up and let you prepare for your tests and quizzes tomorrow. That was, what was that? That was sketching graphs.